Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of dark matter, the invisible substance making up most of the universe. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. Everything you can see, every star, galaxy, planet, atom, and particle of visible matter in the observable universe makes up approximately 5% of what is actually out there. The remaining 95% consists of something we cannot see, cannot touch, and cannot detect directly with any instrument we have built. Dark matter, 27%, and dark energy, 68%. Dark matter is not a theory about something exotic or fringe. It is the mainstream scientific conclusion from multiple independent lines of evidence across multiple scales of the universe. We know dark matter exists because its gravitational effects are measurable. What we do not know is what it is. Despite decades of searching with the world's most sensitive detectors, no dark matter particle has ever been directly detected. The universe's dominant ingredient remains invisible and unknown. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the expanding frontier of unexplained cosmic phenomena, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. The scale of the universe is so far beyond ordinary intuition that even physicists struggle to hold it in mind. The observable universe contains an estimated 2 trillion galaxies, each containing hundreds of billions of stars. The Milky Way alone has between 100 and 400 billion stars. Conservative estimates suggest that 1 in 5 of those stars has a planet in the habitable zone, the orbital range at which liquid water can exist on the surface. That gives our galaxy alone somewhere between 20 and 80 billion potentially habitable worlds. Against those numbers, the claim that Earth is the only planet to have produced intelligent life seems extraordinary. The statistical argument for extraterrestrial life is almost overwhelming. And yet we have no confirmed contact, no artifact, no verifiable signal. The contrast between the mathematical expectation of abundant life and the apparent emptiness of the cosmos is the Fermi paradox, and it is one of the deepest unsolved problems in science. The paradox has generated dozens of proposed solutions. From the Great Filter hypothesis, some catastrophic barrier prevents civilizations from becoming spacefaring, to the zoo hypothesis, they are watching us but not yet making contact, to the simulation argument, the universe we observe is itself an artifact. None of these has been confirmed. All of them have troubling implications. The Fermi paradox is not a curiosity. It may be the most important question the human species has ever faced. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns in science demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding dark matter, the invisible substance making up most of the universe, is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. The existence of dark matter was first proposed in the 1930s by astronomer Fritz Zwicky, who found that the velocities of galaxies in the Coma cluster were too high to be held together by the visible mass alone. He called the missing mass Dunkel Mutterai dark matter. This single data point, if taken in isolation, might be set aside. Anomalies happen. Instruments malfunction. Researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered Vera Rubin's measurements of galaxy rotation curves in the 1970s provided compelling evidence that galaxies contain far more mass than is visible. Stars at the outer edges of galaxies orbit at the same speed as stars near the center, which is only possible if the galaxy is embedded in a halo of invisible mass extending far beyond the visible disk. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine gravitational lensing, the bending of light from distant objects by the gravity of intervening matter, provides another line of evidence for dark matter. The Bullet Cluster, two galaxy clusters that have passed through each other, shows clearly that the gravitational mass, detected by lensing, is separated from the visible and gas mass, direct evidence that a non-interacting invisible substance makes up most of the mass. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, the cosmic microwave background, the afterglow of the Big Bang, contains a pattern of temperature fluctuations whose specific acoustic peaks depend on the ratio of dark matter to ordinary matter. Analysis of these peaks by the Planck satellite confirms dark matter comprising approximately 27% of the universe's total energy content. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of the most favored dark matter candidates are WIMP, weakly interacting massive particles, particles that interact only through gravity and the weak nuclear force. WIMP are predicted by supersymmetry theories. Despite increasingly sensitive detectors including LUX Zeppelin, Panda X, and Xeno NNT, no WIMP detection has been confirmed. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. Alternative candidates include actions, extremely light particles, sterile neutrinos, primordial black holes, and de-modified gravity theories that dispense with dark matter entirely. The strong evidence from the Bullet Cluster and CMB makes modified gravity theories difficult to maintain as a complete replacement for dark matter. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations. And in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain dark matter, the invisible substance making up most of the universe. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that dark matter consists of undiscovered particles, most likely WIMP, actions, or sterile neutrinos, that interact only gravitationally and possibly through the weak force. These particles were produced in the early universe and have been gravitationally influencing cosmic structure ever since. This is the mainstream scientific hypothesis. This interpretation has significant academic support and is backed by substantial evidence, but it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that dark matter is not a particle at all, but an effect of modified gravity. Our understanding of gravity is incorrect at large scales, and what we interpret as missing mass is actually the behavior of gravity in a regime we have not correctly characterized. Modified Newtonian dynamics and its relativistic extension TVS are the principal modified gravity theories. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that dark matter consists of primordial black holes. Black holes formed in the early universe before any stars existed, with masses potentially ranging from substellar to millions of solar masses. These would be detectable through gravitational microlensing, which has constrained, but not eliminated, this possibility. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers, working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding dark matter, the invisible substance making up most of the universe, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence. Material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes: the bullet cluster observation is the single most compelling evidence for dark matter as a substance distinct from ordinary matter. The separation of gravitational mass from visible and gas mass directly shows that a non-interacting component dominates the mass budget. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented galaxy rotation curves, independently confirmed in thousands of galaxies, systematically show that visible matter cannot account for the observed rotation velocities, requiring additional invisible mass in all cases. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed the CMB power spectrum, analyzed by Planck with extreme precision, requires a dark matter component to produce the observed acoustic peaks, independently confirming its existence at cosmic scales. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding dark matter, the invisible substance making up most of the universe. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Dark matter remains one of the central unsolved problems in physics and cosmology. The next generation of detectors, including Darwin, ultimately sensitive to solar neutrino backgrounds, the Action Dark Matter Experiment, ADMX, and the Rubin Observatory will either detect dark matter or exclude many of the most favored candidates. If WIMP are not found in the next decade of searching, the theoretical landscape will need to shift dramatically. Dark matter is real, its nature is the mystery. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis. And the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of dark matter, the invisible substance making up most of the universe, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of dark matter ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.